Okay, good afternoon, everybody. We'll just give it a couple more minutes to welcome in. I can see a couple more participants coming on board. So in a few minutes, we will start our webinar and I'll be back to introduce us. Okay, talk to you in a few minutes. Okay, good afternoon, everybody, and welcome aboard. Thank you for taking the time to come and join us in this COREx webinar. My name is Sheena Fennell, and I work here in Earth and Ocean Sciences. So I'm going to just give you a little background on COREx, some housekeeping on this webinar today, and then I'll introduce our speaker, who we're very thankful to join us, is Dr. Glenn Nolan. So COREx, for some of you might know about us, but it's the Centre of Ocean Research and Exploration here in NUIG in Galway. And it's a research centre with a number of PIs, basically anyone who is involved in ocean research throughout the schools in NUIG. And we come together, and it is coordinated and chaired by Professor Louise Alcock. Unfortunately, she can't be with us here today, so she sends her apologies. So COREx aims to run these ocean seminars about every 4 to 6 weeks, and it's nice to be able to kick this off with Glenn. So our next series will be in about 4 to 6 weeks, and it's going to be with Martha Farrell. She's the Secretary of the Maharees Conservation Association in Kerry, and she's going to be talking to us about the challenges that face coastal communities, mostly around those changes around human impacts on the environment that they live in, and also climate and how they can be addressed. Do follow both the Ryan Institute and COREx on Twitter, and we will be broadcasting or publicising our events by there. So on to our housekeeping. Firstly, welcome anyway, and Payman and I will be in the background. Payman works here in the Ryan Institute and has been fundamental in setting up the IT associated with this webinar, and also for helping me publicise this event. Now on to our speaker, Dr. Glenn Nolan. He graduated here from NUIG in 2002 with a PhD from Earth and Ocean Sciences, and then he became the section manager in the Oceanographic Services in the Marine Institute. In 2015, he took a 5-year career break and became the Secretary General of Eurogoose. Now, Eurogoose might be familiar to some people and not to others. It's basically the European component of the global ocean observing systems. And his main responsibility was enhancing collaboration and also identifying kind of key priorities for oceanographic observation systems throughout Europe. He came back to the Marine Institute here in Galway this year, and he's now head of Climate and Oceanographic Services. And he's going to talk to us today about observing and forecasting Ireland's ocean. We would love you to ask questions, and if you see at the bottom of your screen, you will see there's a Q&A function. So please do, as the seminar progresses, pop in your questions and answers there. I will coordinate them at the end of Glenn's talk, and we'll put them to him. Okay, so again, very warm welcome, and thank you all for joining us. And I will pass over to Glenn.
Thanks very much, Sheena, and it's a pleasure to come back and talk to what are probably mainly colleagues from NUI Galway, where I spent a lot of happy time in my life. I was an MSc and PhD student there in the Oceanography department, which then became the Earth and Ocean Science department, and so I have very very, very fond memories, and I got great tuition and guidance from people like Martin White and Peter Bowyer and Paul Ryan and other colleagues like that throughout the years. Tom Fury was the senior technician there, who many of you know. But those guys really kind of helped ground me in oceanography, and I'm forever grateful for that. Sheena, I'm going to leave the video off. I think that's what you've asked me to do. So, or maybe I'll put it on. Okay, so that's what I look like. And I thought it was funny that in Sheena's introductory slide, I think I was wearing the same shirt as I am today. So I didn't know we'd be so coordinated. But I'm just going to try to share my screen and run through this presentation and give you an insight into how we monitor the ocean around Ireland and how we forecast what's going to happen in the coming years. I hope you can all see that. Sheena, you might just give me a heads up that you can see the slides.
Yeah, that's perfect, Glenn.
Okay, great stuff. So for the next little while, I'm going to talk about ocean observations that we do in Irish waters, some of the forecasting that we do to predict the period ahead. And I'm going to talk a little bit about the practical applications of that, because we don't make observations in isolation. We do it for a reason. We usually have a very, very strong societal driver for making the observations in the first place. And I'd just like to acknowledge my two colleagues here, Caroline Cusack and Thomas Dabrowski, who lead the oceanographic and ocean modeling teams respectively, as they would have provided an awful lot of the background for this presentation. So the structure of the talk, if you like, is that I'll just very briefly on one or two slides tell you about the Marine Institute. I'll say why ocean observing is important. I'll talk about the observations that we make. I'll describe very briefly the forecasting capability and focus in more on the services to users that we deliver and some of the examples of those services, so that you can hopefully see a value chain from data collection all the way through to useful information that people can use as the basis for decisions that they need to make in the ocean. So the Marine Institute is a national agency. There aren't lots of these dotted around Ireland. There is one national agency for marine research, and our job is to undertake, coordinate and promote marine research and development in Ireland. And we basically do this to underpin economic development in that area and to ensure that the marine environment is protected at the same time. And we have an overarching strategy or a marine plan for Ireland called Harnessing Our Ocean Wealth. And that gives a very good overview of where the opportunities are in the ocean and the things we need to protect and take care of as we develop our marine resource. So Ireland has a marine territory of 880,000 square kilometres, and around 40% of our population lives within 5 kilometres of the coast. And in order to make kind of key decisions around what they call blue growth, which is anything around the economy of the ocean, trying to derive value and benefit from the ocean, is called blue growth. And obviously data analysis and knowledge about the sea is key to enabling this kind of blue growth. So I want to just talk about why we observe the ocean in the first place. I'm sure most of you guys know this better than I, but it's just a reminder more than anything else. We need very high quality information, sometimes collected in real time, and often for long durations, like for decades or multiple decades, to detect changes in the ocean. And they have lots of implications that I'll talk about later on. We also need to deliver information in real time for marine weather and ocean services to underpin things like ship routing, safety of fishing vessels at sea and so on, oil spills and those types of applications. We also have to feed into scientific assessments of the ocean, and we have to be able to say how our ecosystems will respond to changes in the physics of the ocean, because I'm mainly focused on the physical attributes, things like temperature, salinity, waves, currents, eddies, mixed layer depth, all of these kinds of physical variables, but they have a major implication for the living resources in the sea, and we have to make that link back to our fisheries colleagues and our marine environment colleagues as well. So you'll be aware that the IPCC, the Intergovernmental Panel on Climate Change, in a recent report has shown that it's very likely that the Atlantic meridional overturning circulation is projected to weaken in the coming decades to centuries. It's high confidence that changes in the ocean have an impact on marine ecosystems, and there's high confidence that coastal communities are exposed to some of these hazards. And the typical hazards are things like tropical cyclones, changes in sea level and flooding, marine heat waves, sea ice loss, and thaw of permafrost, which maybe is less of an issue in Ireland, but as we go a little further north, permafrost thawing out is a huge issue. We also have a lot of drivers at the international level. These are just snapshots of different report cards and drivers. I mentioned harnessing our ocean wealth already. And there is, you'll probably be aware, a climate action plan for Ireland, which is developed. It's an all of government's climate action plan, which is basically to help government departments and local authorities to think about both climate adaptation and climate mitigation. So mitigation in terms of reducing greenhouse gas emissions, but also adaptation in terms of adapting how a sector works to make sure that we can make the most of the changes that are coming down the tracks due to ocean climate change. So you know that the last few years have been very, very warm. This is just a NOAA image of the land and ocean temperatures in 2019, and you can see that the amount of heating is extreme in most places on the earth. And off Ireland, you can actually see record warmest year in 2019 in the ocean, and much warmer than average over our land area in the upper part of this graph. You also know that we are looking at greenhouse gas emissions, and this is for carbon dioxide and for methane and for radiative forcing. You can see that under different emission scenarios, which are the color-coded lines in this plot, out to 2100, depending on how we live our life and whether there's a Paris Agreement upheld and the type of pathway that we take in terms of the amount of carbon dioxide and other greenhouse gas emissions, we will have varying degrees of change in our climate system. And we believe that under most scenarios that we're going to see continued increase in CO2, which has impacts on the ocean, which I'll talk about in a moment. And also there's going to be changes in things like methane as well and other very important greenhouse gases. So we know that the Atlantic is changing. We've already seen this, and this is a very elegant diagram prepared by Jared McCarthy in Maynooth University, just to show at a very broad level the circulation of the Atlantic Ocean that's relevant to Ireland. So you can see the big red arrow in the middle, that's the North Atlantic current. You can see the blue loop that goes around through the subpolar region. That's called the subpolar gyre. And on green, superimposed on this, are what you might call the standard observation points, where we look at continuous monitoring of different water masses in the Atlantic Ocean. So you have an array called OSNAP. You have another one called NOAC, which is done between Germany and Ireland and our Canadian colleagues. And you have one at the Greenland-Scotland Ridge as well. You saw the NOAA image a couple of minutes ago with the very hot spot off the coast of Ireland in 2019. But in 2015, we were experiencing some of the coldest sea surface temperatures that we've recorded in the subpolar North Atlantic. So we need to understand the difference between the general warming that takes place in the ocean and then these kind of superimposed things like increased freshwater and particularly cold years and what they call the cold blob that persisted in the Atlantic for a few years up until maybe last year. We need to understand how these things work and how they impact on the orange arrow that you can see on this map, which is the Irish coastal current or the shelf edge current. We need to understand how the wider Atlantic impacts on the shelf region. So I mentioned the subpolar gyre a moment ago. This is some very nice work that Penny Holliday and colleagues in Southampton have just published in the last few months that shows the subpolar gyre, which is that big blue blob on the rightmost plots that you see there. And under different wind conditions, that subpolar gyre will either expand or contract. If it expands, what it tends to do is it tends to push over towards the European margin and shut down the production of shelf edge current water, which is warm, salty water that comes from the south. And when the subpolar gyre contracts, it means there's a much stronger, faster flow of shelf edge current water from south to north along the coast of Europe. So these, again, are things we need to understand. We also, just switching slightly from physics to a little bit of chemistry now, we also monitored in our waters for ocean acidification. So not just warming, but acidification as well. Changes in oxygen, in particular, the loss of oxygenated areas in the ocean, changes in the supply of nutrients and things like that. And we're already seeing changes in our coastal seas because of changes that we've observed out in the open ocean. And we need to look at things like toxic metals in the ocean as well. And we have to very closely monitor pH. And pH is actually, it's a sustainable development goal target of the UN to monitor pH and ocean acidification. So we're mandated to look at that on a continuous basis. And we do that, and I'll talk about that in a few minutes. We also need to look at plankton. In the upper right-hand side of this plot, you can see changes in the cold and warm water plankton species. These are zooplankton. And you can see that the cold water species have kind of been enhanced in our waters. In the last, well, the warm water species in particular, we can see big changes in the Celtic Sea if you compare the 1960s with the 2010-2015 period. So these are some of the changes that we've seen over the last 50 years. And this has major implications for fish stocks, because fish tend to feed on some of these plankton that we see in these plots here. So this is a Calanus, which is quite a common. It has a warm and a cold water species, and it's a very, very important species from the standpoint of fisheries. But one of the things we don't do actually is monitor zooplankton, which is a gap in our monitoring as a nation. The other nice thing to say about Ireland is that predicting what's going to happen in the ocean in a coming period is kind of the holy grail. It's what we'd love to be able to do. It gives our fishermen and women a competitive advantage if we can tell them a little bit about what's going to happen in the coming season or the coming year. And the good news is that we live in one of the most predictable parts of the global ocean. And a lot of the work that we do is towards trying to predict how oceanographic conditions will change and consequently influence the distribution of different fish species. So that I guess is the good news, that there is some confidence that we can predict oceanographic features that will impact on the distribution of fish. So we also have issues around sea level rise. I mean, most of you have seen this, and we've seen around just under 4 millimeters a year over the 20th century. This is at a global level of sea level rise. Jared McCarthy and colleagues in Maynooth have looked at this, and they've actually analysed the tide gauge data from Dublin, which extends back nearly 100 years. And they reckon that the rate of increase is more like 10 millimeters per year for that particular location. So these are some of the things that we really need to understand. And part of the monitoring programs that we have are to understand some of these changes and to separate out some of the major trends that we see in sea level over time. So our sea level is projected to change somewhere between 0.7 of a meter and a meter by 2100, depending on which emission scenario that you use from IPCC. So that would be very serious. I mean, I'm sure you've been in Galway or other parts of Ireland where you can actually see a storm surge getting very, very close to breaching the seawall. And if you added 0.7 of a meter to that level, you'd have very, very substantial flooding. And these are some of the things that we're trying to understand. And the other thing to say about sea level change is that it won't impact all areas of the coastline evenly. Some areas will be more heavily impacted than others. And I hope you can see on this plot on the right-hand side that the south and west coasts of Ireland are more likely to be heavily impacted by increased sea level compared, say, to our friends in the Irish Sea or in Northern Ireland or even parts of Scotland. So the west coast of Ireland and the south coast in particular are likely to be very vulnerable to sea level change. And this is under a business as usual scenario. This is to try to keep burning fossil fuels the way we do now, keep driving diesel cars, keep living our life the way we do, generating the waste that we do, and so on. So it's a big deal, and it's something we need to really keep an eye on. So I'm just going to talk for a few minutes about what we measure, and I'll go through this very, very quickly. We need a variety of things to kind of give us the ability to make decisions in the ocean. We need in situ technology, and I'm going to talk about that. That's technology in the ocean that measures and monitors things. You need to combine that with model and satellite data. We need data archives to store this information. We need tools that allow us to interrogate the data sets, and this hopefully leads to decisions and actions that we can take based on the interrogation of these different data sets. So this is a kind of one-stop shop plot of all of the different observing programs that we have on the oceanographic side in the Marine Institute, and Sheena was involved in the setup and delivery of many of these programs, including what we now call the Marine Data Buoy Network, the Tide Gauge Network, which measures sea level all around the coast in about 20 locations. We have a Wave Buoy Network. We have a cabled observatory in Galway Bay. We have glider programs, which are all around autonomous vehicles. The Marine Institute now has 3 or 4 of these autonomous vehicles that go out and make measurements. We have landers on the seabed that sit there for periods of time and make measurements. And we have other coastal data buoys that we put in place for local applications, which I'll talk about near the end of the talk. So again, these are just snapshots of some of the technologies. I don't really have time to go into detailing what each of the technologies do in a huge amount of detail. But just to give you a flavor of some of the technologies, from remotely operated vehicles to moored systems to ship-based systems and so on. We use a variety of things to monitor the ocean. So this is the National Tide Gauge Network. There's 18 operational tide gauges around the coast. You can see them with the red dots on the map here. We maintain this network on behalf of the Irish public. We feed it into the real-time monitoring systems for sea level change and for coastal inundation and flooding. What does the data look like when they come out of these tide gauges? You can see here, I hope, some plots of different storms that came through a few years ago, where you can see changes in the sea level. If the tide is doing its normal thing, it just undulates up and down between spring and neaps. And that's a little bit like the green curve that you can see on the right-hand plot here. But superimposed on that are the actual observations. And this is one from Kinvara, where we actually had a double high tide, where the tide started to come in, then got pushed back out by the wind and started to come in again. So you can't say that the tide is just completely repeatable. It gets effects superimposed on it. And these 18 or 20 tide gauges help us understand some of these local effects and to predict what's going to happen in real time, whether the Salthill Prom is going to get flooded or whatever. We have lots of intelligence there that we can feed into the flood forecasting system. So we also monitor ecosystems, and a lot of what we do is about fisheries data collection, looking at larger marine mammals, looking at plankton, in particular phytoplankton, the smallest plankton, and trying to put all that together into an understanding of our marine ecosystems, and then feeding that into fisheries advice that our colleagues in the fisheries service team here use. We do that in a few different ways. We use our two very nice research vessels. We have the Celtic Explorer, which is 65 meters in length, and the Celtic Voyager, which is a little bit smaller, a good bit smaller, 31 meters. We have a new vessel coming on stream in 2022, which will be somewhere in between the size of the Celtic Voyager and the Celtic Explorer. And we also have what they call a remotely operated vehicle, which is in the lower right-hand picture, that can go down to 3,000 meter and can pick up things off the seabed and measure and monitor different things, use high definition cameras, and really get a very good understanding of our seabed and ocean ecosystems. One of the other things we do is we do what we call a climate survey in the Rockall Trough. So I hope you can see these yellow dots superimposed on the map. This is where we go out and take routine measurements of a lot of different ocean parameters, from the physics through the chemistry through to the biology. And we've been doing this since the early 2000s. We've been going out on this section. Martin White and colleagues in NUIG have led some of this work as well. And we try to monitor this, what we call this standard section in the Rockall Trough, at least once a year if we can. And that then gives us some context for what's happening on the shelf region as well. So the other thing we do is we instrument some of the buoys and the networks that you saw in one of the original plots. So here's a picture of an offshore weather buoy, and kind of superimposed in between these weather buoy pictures is a mooring picture of all of these different temperature and salinity measuring devices that we put along the chain between the surface and the anchor at the seabed. And just for context, this anchor is down at 3,000 meter water depth in the case of one of our moorings. We instrument that all the way up to the surface, and we can then tell what all the major water masses in that part of the Atlantic Ocean are doing. And we can analyze that, and we can look at changes in those water masses over time as well. So we also use our ships to good effect. We have a lot of underway systems on the ships, including systems that measure partial pressure CO2. The green track that you see in the middle there is the track of the Celtic Explorer that has a very nice self-calibrating PCO2 measurement system on board. And we can use that to monitor the carbon in our waters at any given time. And this gets sent into an international database, which is called SOCAT, which aggregates all of the carbon data in the world in a single database. So we feed into this SOCAT database. So for any of you who are starting MSCs or PhDs and you're looking for carbon data, or you're looking for an interesting research topic, this is certainly a very interesting research area, and all of the data are freely and openly available to students to use. So we also look at the carbon in the inshore waters as well, and this is just some examples of where we sample in the inshore waters. This is typically ship-based sampling, where we look at things like total alkalinity, dissolved inorganic carbon, and we do that at all these points at least every year or so to try to see what the changes are over decadal timescales. We recently got a shot in the arm from Science Foundation Ireland, who agreed that a lot of our infrastructure was getting quite old, and they agreed to help us upgrade the offshore data buoy network, formerly the weather buoy network. They gave us money to buy new moorings for the shelf edge, to understand the shelf edge current a little bit better, to upgrade some of our tide gauge sea level stations around the coast, and also to purchase 2 new gliders, autonomous vehicles. So that's a fantastic boost for the country, and we're in the process of implementing that with our colleagues in the Marine Infrastructure Group here in the Marine Institute. We have a test and demonstration site in Galway Bay called Smart Bay, which you may or may not be aware of. It's an ocean energy test site, and we have a fully cabled underwater world, if you like, at that test site. So you can come and plug in an experiment at this test site, and you can run experiments and do various scientific endeavors at that test site. The nice thing about it is that you have unlimited power and unlimited bandwidth. So you're not constrained by radio transmission or by batteries in your instruments. You have a full, 220 volt, basically like having home electricity and home broadband on the seabed in Galway Bay. So it's a fantastic asset to have. That's just a close-up of what it looks like in a kind of schematic sense, with different gliders, docking, and Doppler current profilers and so on. And that's the actual in-water infrastructure being deployed. That's what the cage looks like that has all of the subsea equipment on it. That's what it looks like for real. We also contribute to the Argo marine research infrastructure. Argo are profiling floats that go down to 2,000 meters in the ocean and make a profile every 10 days. And when the float breaks the surface of the sea, it sends the information back to shore for analysis by anybody in the world who wants it. Again, this is open, free and open data, and anybody who wants to learn more about the ocean can access Argo data in this way. Mapping our seabed is very important, and Ireland has spent a lot of money over the last 20 years mapping our seabed. And my colleague Tommy Fury here, whose dad used to be the senior technician in the oceanography department in NUIG, has led this program for the last 20 years, more or less, to map our seabed. And you can see the colored in area is the area that we've actually mapped of our seabed. This is just a close-up of Galway Bay. You can see the very nice resolution of the seabed maps. This is critical to ocean monitoring and forecasting, because bathymetric maps affect how the bathymetry affects how currents flow over those regions. And this is just a real close-up in a portion of the North Sound of Galway Bay. You get a real appreciation of the detail, the fine detail that these maps generate. So what can we forecast? This is just a single slide. So I'm moving from observations to forecasting. Just to give a quick flavor, we can forecast the hydrodynamics. So there are things like the temperature, salinity, currents, sea surface height. We can forecast what's going to happen with waves in the coming days. We can look at the biogeochemistry of the ocean, things like chlorophyll, nutrients. We can look at sediment loads, different things like that. We can also look at shellfish and how quickly they'll grow in the ocean. We can move things around like oil spills and see where they're going to affect. We can look at where fish larvae are going to go. We can track their ichthyoplankton, and we can also do climate modeling. So for the last few minutes of the presentation, I'm just going to focus in on some of the applications of the combination of observations and models to give you a flavor of how they're applied in real life. So the first example is in the context of ocean energy. So ocean energy devices are being developed all around the world. We have, with our colleagues in the Sustainable Energy Authority of Ireland, a test site up off Belmullet. So this complements the one in Galway Bay. It's a full-scale ocean test site for renewable energy devices. And a lot of the time, the people who use these devices and who are testing them and developing them, they need to know about the environmental context that those devices are working in. In particular, they need to know the wave height. They need to know that a storm isn't going to completely destroy the device that they're putting in. So they need real-time wave and wind conditions, and need lots of information about the tide and various other things. And this dashboard that we've set up, and the URL is there in yellow. I'm sorry, the font isn't very clear. You can go straight to this dashboard and you can get that information in real time from these sites. And energy developers use this in real time to underpin the running of these sites. These are just a quick snapshot of some other examples. We can look, as I mentioned a moment ago, at what we call the carrying capacity of shellfish. We can look at, given the amount of nutrients in a bay and the amount of chlorophyll and various things, we can work out how quickly mussels will grow in a particular bay, and we can feed that into shellfish farmers, and we can We can feed that into the licensing process as well. We can also look at how these same shellfish sites are contaminated by microbial activity like E. coli infestations and things like that. We can help our parent department in the Department of Agriculture and Fisheries and the Marine to figure out where are the next places you can do aquaculture. So where are safe sites where you can do aquaculture in terms of wave exposure, of strong currents, all of these kinds of things, how quickly contaminants will disperse from different sites. And we can also do things for our fisheries colleagues in terms of generating bottom temperature maps, which have an impact on the recruitment into a fishery and whether a stock will collapse. And we also forecast things like harmful algal blooms, which is where you get a bloom of very, very small plankton, but you get tens of millions of them. And in that concentration, they can really cause havoc to finfish aquaculture in particular, to salmon farms. So these are just some ideas and some applications that we have developed. The other thing that anyone working offshore is very interested in, I mentioned it in the context of ocean energy, is weather windows. So when can I safely go out and operate my fish farm or my ocean energy test site, or whatever it could even be a leisure application. Can I go out kite surfing today, or can I go out windsurfing or sailing or whatever it is? So we have a lot of these kind of things that help us to define thresholds where people can decide, look, the weather conditions are going to be above this threshold for 2 days, so it doesn't make any sense to plan any activity in the coming 2 days. So we just call that weather window calculation, if you like, or weather window tools. We also support our parent department with things like oil spills, and the lower panel shows an actual oil spill that took place in 2009 where a Russian aircraft carrier discharged oil in the Celtic Sea. And we had to look at where that oil spill was going to go and whether any fisheries resources were going to be impacted by the oil spill. So that's quite a typical application of the models and the observations to work out where things are going to go in the sea. Another example, I hope this movie plays, but yeah, it's working. Okay, cool. Is we do a lot of work on search and rescue. And sometimes this particular application is for cold cases that the Garda Síochána were looking at, where they wanted to look at, you may have heard this in the media a couple of weeks ago, where people, unidentified people washed up in Wales and maybe were buried a couple of decades ago. And they wanted to try to trace back where these people might have come from in the first place, because they need to have some evidence to exhume somebody's remains, to do DNA testing on them, to connect them back to their family. So it might seem like a very obscure application of oceanography, but this is something we get asked by the guards to do maybe 4 or 5 or 6 times a year. So this kind of tracking of casualties when they go into the water is quite a common application of oceanography. Another area where we provide information is to sailors, and this is just an example from the Fastnet race. You can see in the lower panel, the green panel, what the sailor might think is the fastest route from the UK to Ireland, this straight line route. But actually the fastest route, when you look at the prevailing wind conditions and the prevailing currents, is actually that blue line that you see in the plot. So we can do this route optimization planning as well. And that helps in particular smaller vessels to plan their routes around the Irish coast and things like that. So this is another typical application. I wanted to say that all of our data are available. We're a public service agency. All of our data, model output and observations are available through what we call an AirDAP server, which the URL for that server is here. And I'll send this slide on to Sheena and Payman afterwards so that you have the URL. But please go and have a look at the AirDAP site and make use of these data, because they're there for the Irish taxpayer pays for them. They're available for research and for study and for commercial endeavor. And so please, make use of these things as much as you can. And as I say, I'll send around the URL after this again. I want to just very briefly, and I'm very close to the end now, you'll be happy to hear, you can go back to eating your lunch if you're not already doing that. I wanted just to kind of map out the landscape in which Ireland is going to respond to the climate crisis. So we have, as I mentioned at the start, a climate action plan, and you can see that in the blue box near the top of this plot. And many different government departments have to produce adaptation plans. So that is, how are the sectors that you're responsible for going to respond to the climate challenge? And there are many different government departments. I'm not going to go into detail here. The blue boxes at the bottom are kind of the different things that the Marine Institute does to underpin some of these adaptation plans. So we have projects that we fund. We have funded projects in NUIG and Maynooth and UCC and other places. We fund PhD students, we fund postdocs, We've just advertised the call actually for a new climate postdoc and PhD student, which may be of interest to some of the people listening in on this webinar. We have our own infrastructure, our ships, and a lot of the stuff that I've described in this talk. We generate an awful lot of data which are available in the AirDAP environment that I talked about. And we have to think as an institute about how we serve all of these different users in different government departments. And we also have 31 local authorities in Ireland who also have to have an adaptation plan for climate. So at the moment, we're scratching our heads trying to figure out how we can best configure, with the resources we have, our response to some of these adaptation plans that the different government departments have. So again, this is just to show you a little bit about the application of the science in terms of climate adaptation. So if we're to develop a climate service, we need to identify the user needs. This is talking to the different government departments. We need to think about what we need to measure to meet those needs. We need to integrate that with models and satellite imagery potentially. It has to be a user-driven product development. It can't just be a bunch of scientists in the MI second-guessing what the users need. We have to be able to deliver a useful product to our end user, and they need to have a mechanism to feed back to tell us it is or isn't good. So that's kind of the framework that we use to deliver climate services. And a lot of these climate services will be delivered with Met Éireann and with other players, the Geological Survey of Ireland, possibly with the Office of Public Works and other entities to co-develop a lot of services for the different government departments that you can see there. So I just wanted to finish with a picture of a model that we've recently set up for Southwest Ireland. It's set up in the context of a project called Coastline, which is funded very heavily by our EPA, our Environmental Protection Agency. We've run a forecast, a projection for 2006 to 2035 for two different emission scenarios, the RCP 4.5, which is a kind of mid-level emission scenario, and 8.5, which is the kind of accelerated emission scenario that I showed in some of the plots earlier. We used the same model that we use for our operational forecasting, which is called RAMS. And we have now produced this projection for the next 30 years. And we also have a historical run that covers the period between 1976 and 2005. So every 1 kilometer in this model domain, 1 to 2 kilometers in this model domain, and at 30 different vertical levels, we can tell you what the projected change in temperature, salinity, sea surface height, currents, any of the physical variables, we can tell you what that's going to look like in 2035. Now, there's lots of errors in climate models as well. I have to qualify that. It's not we're trying to predict what's going to happen 20 years in the future. I mean, we can't get the weather forecast right 5 days in the future. So I have to put a caveat on some of this, but it is a very useful tool to underpin future policy. If you think that a particular area is going to heat up more, or it's going to have more harmful algal blooms, or it's going to have less capacity to grow shellfish, you can make adaptation decisions based on that. And I think it's going to be a very useful tool in the future. And we do plan to extend this model to the full domain, the whole of Irish waters, coastal waters at least, and run the model out to 2100 under different greenhouse gas emission scenarios. So I hope that's given a good overview. I just want to show you one final plot, which is this is not a projection, but this is actual analysis of plankton data from the National Phytoplankton Monitoring Program at the Marine Institute. And we've divided the period into two, where the red color is the period between 1997 and 2006, and the blue color is the period between 2007 and 2016. And what we're doing here is we're plotting the number of cells on the y-axis against the month of the year when we see those cells. And I think what you can see for one of these species, which is called Dinophysis, we can see a shift towards later months of the year for that species. If we just look at not the earlier decade against the more recent decade, but we also see quite an increase in the number of cells that have been produced in those months as well. So that has implications for aquaculture and for lots of other things. And another related species, actually kind of in the same family, it doesn't show the same trend. It shows actually what you might call a double peak, where you have quite a strong spring bloom and quite a strong autumnal bloom. But that's a move away from quite a summer-centered distribution that we had in the period between 97 and 2006. So these are just some of the little tantalizing things that we're seeing in the climate context in Ireland. And in the next 1 to 2 years, we'll produce a new climate status report for Irish waters, which will document a lot of these changes. So I hope that's been a useful fly through the different things that we do in the Oceanographic and Climate Services team, and I'd be very happy to take any questions that you have. Thanks very much.
Thanks, Glenn. Thank you for an excellent presentation and loads of information. I have a couple of questions coming in here. So from Eugene Farrell, he said, thanks, Glenn, very informative talk. Is there any appetite here to replicate the UK Southwest Regional Coastal Monitoring Programme for storm inundation hotspots, which are linked to wave run-up? And that programme is coordinated by Plymouth Coastal Observatory, and data is shared with all end users.
It's a very good question, and I'm only kind of mildly familiar, I'd say, with that programme. But our interaction so far with our colleagues in the UK has been in a more general sense with what we call the Marine Climate Change Impacts Partnership, or MCIP, and that's kind of driven through the DEFRA government department in the UK. And I know colleagues in Plymouth feed into that MCIP process. I know same people that run the Coastal Observatory also feed into MCIP, to the Climate Impacts Partnership. So it's one I'm going to take away and have a look at and see whether there might be lessons we can learn from that. It's great that you've brought it to my attention. But as I say, up until now, our activity has been very much at a kind of a general level, and we need to, as we understand the adaptation plans a little bit better for the different sectors. I mean, there is, for example, a flooding sectoral adaptation plan. So we need to look at that very carefully to see how we can tailor some of the services that we provide to feed into that flooding adaptation plan. And that example from Plymouth could be a very good, case study that we could potentially learn from and maybe develop new services based on that.
Yeah, so thanks, Glenn. I suppose Eugene works quite a lot down in Kerry as well on run-up, so I'd say that's linked into that. Okay, from Rachel. Hi, Glenn, excellent talk. Could you comment on how we might need to make our coastal planning mechanism more versatile and proactive to cope with the likely impacts of climate change on coastal waters?
Rachel, I can always depend on you. I presume that's Rachel Cave. I can always depend on Rachel to ask the tough questions. So coastal planning, yeah, I mean, you'll be aware that there is a new National Marine Planning Framework that has been out to public consultation earlier this year. One of the first jobs I had to do when I came back to the Marine Institute was to figure out how you climate-proof that National Marine Planning Framework. And I guess just to give you a bit of confidence that it isn't something that's been forgotten, climate change really cross-cuts the whole National Marine Planning Framework. The priority for that framework at the moment is to produce a marine spatial plan for Ireland, which has to be done actually by March of 2021. And that's mandated by the European Commission. If that doesn't happen, our country will start to face fines under that directive. So that is a very, very high priority. The Marine Institute has just recruited 8 new people to work on this marine plan and things like the Marine Strategy Framework Directive. So Rachel, just to give you confidence, it is embedded in the thinking. How it'll play out in practice, we know that our foreshore planning bill is going to be updated on the back of this National Marine Planning Framework, and that should allow more, I guess, efficient decision making around planning for marine activities, because a lot of people have acknowledged in the past that it can be a very slow process, particularly around aquaculture and fisheries and those kinds of areas. But for any foreshore license approval can be very, very slow. So it is embedded in the new framework, and I would hope that we would make, as a country, we'd make very serious progress in that regard in the next little while. But marine data and marine observations underpin what will be in that plan. The maps that the planners will make decisions on will be based on marine data sets that we've either already collected or will collect in the very near future. So, and those things will change over time. So we need to update the maps and update the plans as well. So it's not a static process. It's a very dynamic process. So I hope that goes some way to answering that question, Rachel.
Great, thanks a million, Glenn. And just from Brian, can you describe the activity going on at the Galway Bay test site at the moment?
Yeah, it's there were a few problems with in years past we had quite a lot of activity at that test site. with wave energy device developers in particular. And when the Marine Institute went to renew the lease for the second period, so it had a lease for 10 years. When it went to renew it for the second period, there were a lot of objections came out from the local community mainly about the test site, and the activity has been quite limited on it in the last couple of years, probably in the last 18 months at least. But there are still projects that go on. The technology that I showed the picture of, the seabed lander with the Doppler current profiler and cameras and all of that kind of thing, that's still in place, and there are people that are doing science projects based on that infrastructure that's in place. We have also what they call a National Infrastructure Access Program, a NIAP program, which is led by Smart Bay and the Marine Institute, which allows researchers to get access to that observatory. And in any given year, I think that there were maybe 7 or 8 NIAP projects in the last calendar year. So these are individual research groups within universities that are doing research on fish stocks, on benthic species, on air-sea interaction, lots of other areas. And I could probably send Sheena just a follow-up note on some of the projects that are live there at the minute, because I'm not 100% sure what's live there right now, but I can certainly follow that up if people are interested in that.
Great, thanks, Glenn. And from our student, great talk, thanks, Glenn. What advice would you give to marine science undergrads, and what options are available to you once you graduate with your degree before the master's? So I suppose, yeah, within Ireland, or what you would suggest or offer advice on?
I think the options are, I mean, I'm a little bit ahead of many of you guys on the webinar, kind of 20 plus years into a career in oceanography. I mean, I guess at a very high level, I would say it's been one of the most rewarding things I've ever done. It's an incredible privilege to get to work in an area that's scientifically interesting, that you meet the best of colleagues within and outside Ireland. You get to build great networks that last for your lifetime. You get to travel extensively if you want to as part of your work as an oceanographer. And I would say the opportunities are getting more and more as time goes on. When I graduated with a master's, I mean, the opportunities were few and far between. And at that time, there wasn't even a dedicated oceanographic part of the National Marine Institute. There was a couple of people who mainly did plankton, who did a little bit of oceanography in their spare time. We've now built it up to the point where we have oceanographers in NUI Galway. We have them in fairness, we always had them in NUI Galway. It's gone up and down a little bit over the years, but we now have research groups in Maynooth. We have a much larger team within the Institute. We have colleagues in UCC who are doing oceanography, and in particular around the coastal side of things. So I think the opportunities have really, grown, I wouldn't say exponentially, but they've grown steadily over the last 20 years. And I think, I guess one single piece of advice I would have is to try to make sure that the work that you do is as applied as possible, that you have a real life application for the work that you're involved in. So even if you're just choosing a final year project or an MSc or a PhD thesis topic, try and make it as applied as you can. Try and link in with an applied industry of some sort, or even linking into the public policy domain, so that what you do has an implication for the formulation of policy, because these are the ways we continue to get our programs funded. It's by making our research policy relevant and making the information useful to people who have to make decisions on the ocean. That really is the key. And I was on a seminar last week with some of the colleagues in Maynooth, and I was blown away by the applied nature of some of the PhD work that the students were involved in there. And that was a real take home for me, to make sure your research is very applied, because there'll always be lots of people there to do the basic research, but be the person who translates that into something that is tangible and applicable in the real world. I think that would be my fundamental piece of advice.
Great, thanks, Glenn. I'm just going to hop in with a question for myself, if you don't mind. I saw on Twitter yesterday there was a CO2, obviously the Keeling's curve that we're all very familiar of, CO2 going up, and superimposed on it was when all the agreements were put in place, like the Paris Agreement, Copenhagen, Kyoto, and like you could see it was still going up. From your experience in Europe, do you think on a political aspect there is enough buy-in at the top for us to change?
Yeah, I think, I mean, in Europe, in a sense, you're picking the good guys, so to speak. I mean, I would say almost all of the European member states are completely bought into this idea of carbon neutral by 2050 and a carbon neutral continents by that time. And I can see that translated into the national plan, the national action plan, the climate action plan already. And I can see how hard our government are sweating the public and civil servants in terms of making sure that our programs are climate relevant and that they are taking into account some of the larger agreements that you mentioned there, Sheena. So I have a lot of confidence in Europe responding very well to it, and they follow that up with a lot of research money in the climate area. There's major push in the New Horizon Europe program to do climate work. There's a major push to integrate observation at European level, maybe through a European agency in that regard. So Europe, I think, is a good example. And at the other end of the spectrum, you have say people like the small island development states who again are totally committed to climate action because they are really at the cutting edge of being impacted by climate change. So they're really pushing the very large nations to try to do more in the climate space. But the elephant in the room is the US rollback on the Paris Climate Agreement, which I would hope would get immediately resolved if there's a change in leadership coming up. I probably shouldn't be making these political statements, but I know a lot of people feel the same way, that the US really needs to get back in behind the Paris agreements. We also need to convince our colleagues in India and China and the countries that are the large polluters now to get behind some of those agreements as well. So I am hopeful, and particularly hopeful in the European context. I see action on the ground there that gives me confidence. And I see it in our government. I see our government actually taking steps and taking it very seriously. So I'm optimistic that they'll support the right types of activities, that they'll help with the just transition from a high carbon economy to a low carbon economy. I think they get it, so I am optimistic. But you do have to put it in the context that we are a small nation in the scheme of things, and I think we'll act in line with the European need to reduce our carbon as a continent. But then there are other players outside of that who may or may not play ball, so to speak. So it's still a long game. But if they change the US stance in the coming few months, I think that would be a big step forward.
Great, thanks, Glenn. It's good to hear as well, because sometimes I see these things on Twitter and it's quite tough. Okay, there's just one last question from just Brian again. At the moment, are there wave energy devices being tested at Belmullet?
There are no. I can check this, but to my knowledge, there aren't any. You see, the Belmullet site is a full-scale test site, so there are very few technologies globally that are at full scale. A few of them have gotten close, and sadly, the companies involved have gone bust. So I think the short answer is that there's no devices on test there at full scale at the moment, and you would be a little bit foolhardy to test a quarter scale device at a site like Belmullet. I mean, we've measured, and Sheena, you remember this from your old days working in the Marine Institute, that you routinely measure waves that are bigger than 20 meters at that site. So it's not a place that's for the faint-hearted, and you need very, very good engineering, very good logistical support to operate at that site. So there are no devices on site there at the moment, as far as I'm aware. But I can double check that if Brian wants me to look into that. I'll happily do that.
That's great, Glenn. I think we've given you enough questions. So thanks everyone for posing those questions to Glenn. I think we'll all agree that it was an excellent presentation, and great to see such a wide variety of projects within the Marine Institute. So Glenn, thank you very much, and thank you for agreeing to come and start our COREx Webinar Series. Hopefully we'll see you all again in about 6 to 8 weeks. And enjoy the rest of your lunch, and many thanks for coming in and coming by.